All right, so in this lesson, we're going to be talking about the sectors of circles. Okay, so what is a sector of a circle? So a sector of a circle is just essentially a section or a piece of it, a slice of the circle. Okay, so it's equivalent to, a slice of pizza, a slice of cake, stuff like that. Okay, now before we get into the lesson, I quickly want to talk about kind of the more conceptual thing of a sector. Like we talked about arc length. So a sector, or the area of a sector, is what we're really going to be talking about in this lesson, is just a fractional part of the total area of the circle. Okay, so let's just kind of think about this for a second. So if we had a whole circle, okay, the area would be pi r squared. Okay, now if we wanted to find the area of this part, right, so this is a semicircle, so it's half a circle. So to find the area of this part, this section, we would do 1/2 of the total area of the entire circle. So same goes for this, right? If I wanted to find the area of this part, this section of the circle, this is 1/4 of the section, so I would do 1/4 of the total area of the entire circle, okay? So to find the area of the sector, we would do central angle over 360 times the area of the entire circle. Okay? So kind of like we talked about with arc length, we would do this kind of the same way to find the area of a sector. However, we're using the area of the circle formula instead of the circumference formula. Okay? All right, so let's look at some examples. So we're going to kind of skip over exercise 1, but let's look at exercise 2. So we have a patio in the shape of a circular sector, has a radius of 20 feet and a central angle of 110 degrees as shown. Find the area of the sector to the nearest square foot. So again, you want to find the area of this shaded part. Okay, so remember, a sector is just a fractional part of the entire circle. So we're going to use that central angle divided by 360 times the area of the entire circle idea. Now the central angle they have here for this shaded part is 110. So we're going to do 110 divided by 360 times pi, the radius is 20. So pi 20 squared. Okay. So let's get our calculator. So let's do 110 over 360 times pi. Okay. So the area of sector is equal to 383.9724354. Now we want to round to the nearest square foot, so to the nearest whole number, so 38.4 feet squared is our answer. Okay. All right, so let's take a look at the next page. All right, so let's take a look at 3. So a garden has the shape of a circular sector such that its straight sides measure 50 feet in length and the central angle is 132. If the garden needs to be surrounded by fencing, how many feet are needed? Okay, so because we want to find the fencing, this is not area, this is arc length. Okay, we talked about this when we did a little bit, we talked a little bit about this when we did circumference, okay? Now we have to be careful. This entire thing is the garden. So at the end of our question, we need to make sure we add up this side and all of this, okay? So we're gonna kind of use this fractional proportion idea to find the length of this arc. Now, since we're not doing area, we're doing arc length, we're gonna use our circumference formula for this, okay? But it's still the same idea. Okay, so our central angle is 132. So we do 132 divided by 360 times 2 pi, and our radius is 50. Okay, so let's first find what this is equal to. Okay, so this is equal to 115.1917306. Okay, now like I said, we want the total fencing around it all. So we need to add 50 plus 50. So essentially we are adding 100 to this, so plus 100. So our answer is 215.1917306. So round to the nearest foot. Now, I feel like in this question, now they're asking how many feet of the fencing is needed. Now, when we go to the store, when we go to a Home Depot, whatever, and we buy fencing, we can't buy like a certain amount of feet, right, for fencing. So I feel like for this question, we should round up. So we're gonna round to 116 feet, okay? Okay, we kind of have to like think about those things. So let's look at 4. So a sector of a circle whose radius is 5 centimeters has an area of 20 square centimeters. Is the central angle of this sector acute or obtuse? Okay, so a sector of a circle, like we just talked about, is it's just a section of the circle. So this section has a radius of 5 and an area of 20, okay? Now we need to find the central angle in this case. Now we're doing nothing different. Well, we are doing something a little different, but we're using the same type of formula, same idea. Okay, so we're using that same formula, same idea, except we're finding this, okay? So now our area is 20, so we're gonna set our equation equal to 20. Now our central angle is what we're finding, so we're gonna call that x. We're gonna divide this by 360 and multiply it by our area of the entire circle, so pi 5 squared, okay? Now we need to solve for x. We need to solve for the central angle. Now I'm just going to simplify this a little bit, not entirely, to kind of make it a little bit easier to solve for. So I'm just going to say this is 25 pi, because 5 squared is 25. So we have 25 pi. It's just the 5 that is squared, not the whole thing. Okay, so now, first of all, we divide by 25 pi, both sides. Okay, so 20 divided by 25 pi. Be careful of how we put this in our calculators because it's very tricky, okay? Okay, so 25 divided by 25 pi is 0.254647989 is equal to x times 360. Now to solve for x, like I just did in my calculator, as you saw, we're going to multiply both sides by 360. So x is going to equal 91.67324722. Okay. Now, is the central angle acute or obtuse? Now, barely, but it is obtuse because our angle is greater than 90. Okay. All right, so let's look at exercise 5. So a horse attached to a 8-foot long rope can rotate the distance of 128 feet. So a horse is walking along this distance here. Now we want to find the angle that the horse can walk about. Now, because this is the arc length and not the area that the horse is walking around, we are going to use the same idea, but instead of multiplying it by the area, we're going to multiply it by the circumference. Okay? Now, just like we did up here, we are going to solve for the central angle. So we're going to kind of work our way backwards, okay? So we're going to call this x over 360 times 2 pi 8, and our arc length is 28, okay? All right, so like I did up here, I'm just going to simplify this a little bit. So I get x over 360 times 16 pi. Okay, so 28 divided. Now, careful of how we put this in. I always recommend we do this alpha y equals, because otherwise it gives us a really weird answer that we don't want. Okay, so this is 0.55704230008. Now multiply both sides by 360. So x, so multiply this by 360. So our angle is 200.5352283. So round to the nearest degree. So our central angle, or x, or the angle the horse can walk about, is 201 degrees.